الدكتور إرنستو دامياني. صباح الخير دكتور إرنستو، أهلا وسهلا فيك معنا
Morning.
بصباح سكاي نيوز عربية. يعني لو تبسط لنا بشكل أسهل ربما، ما هو هذا الحاسوب الكمي أو الكوانتم كمبيوتر، ويعني ما هو تحديدا؟
Well, first of all, a quantum computer is a physical object. It's not a software, it's not a program. It's a physical object that is composed of a quantum memory and of a quantum algorithm acting on the memory. The quantum memory is different from the ordinary memory. In the ordinary memory, you normally have one value at a time. You have a single value. When you have some bits, with those bits, you represent a number or a string or a character, single one. With the quantum computer, with the quantum memory, the same number of bits can contain, well, all the possible characters, all the possible values. So with a limited number of bits, you can contain trillions of values. And the algorithm needs to extract exactly the value we are looking for. So basically, the quantum computer is simplifying, thanks to its physical structure, computations that in normal computer need to be done one value at a time. If you are searching for a number, you need to look at all the possible values in order to find the one you're looking for. The quantum computer contains all the possible values at the same time. You just have to find the right algorithm to read the one you're looking for, single step. So it will make, well, even faster with respect to the current ICT, the current computers, computations, not all computations. Certain types of computation will be made, well, incredibly faster than they are. And this will change computer science, but it will change also the applications we use every day.
طيب كانت النظرية الكمية اليوم أصبحت عملية. لماذا استغرقت كل هذا الوقت لتصبح في الأسواق بشكل عملي؟ ولماذا عامين لبناء الكمبيوتر؟
Well, let me answer with this. First of all, I remember when it was proposed, the first idea. It was around 20 years ago at the University of Oxford. So the idea, well, is old. The practice is only recent due to the fact that it takes time, money, and engineering ability. At the moment, what we have available are quantum computers with a memory of 5 bits. The IBM prototype, which is the one which is publicly available, has 5 bits of memory. Not 50 or 500, 5. So each of those bits cost millions and millions of dollars because you have to create the quantum entanglement state. This notion that a single bit can contain so many values. Well, this is a physical state. You must put a physical system in. And in order to do that, you need a very advanced lab. And you need to preserve this condition in time. It's a condition which is very, very volatile. Very easily, a quantum bit can revert back to a normal bit. So you have to preserve its condition of being quantum. We are just learning how to do it. For the moment, we can only do it for a limited number of bits, and we can only do it at a very high cost. So we are working on this ourselves here at Khalifa University. I can tell you this is very costly equipment. And this is the reason, mostly the reason, we are learning how to do it. And it's painful learning because you have trial and error. Once you have the system then in place, those computations are as fast as light as I told you before. But you have to keep and preserve that quantum state. It looks easy in a discussion, but it's very difficult in the lab.
دكتور إرنستو، يعني اليوم يعني القرصنة باتت تشكل أيضا هاجسا عند الجميع على المستوى الفردي وعلى مستوى الحكومات. إلى أي مدى اليوم هذه التقنية أو هذه التكنولوجيا قد تلعب دورا إيجابيا أو سلبيا في هذا المجال؟ هل تؤثر عليها؟
Okay, let me tell you something about the negative part first. The negative part is the part that computation so fast can be used in order to find the key to any cryptographic system we have on the internet today. So all those systems that are used from everybody, from the governments, the military, down to the banks, but also by ourselves when we wanted to encrypt our communications using WhatsApp or whatever, all those communications can be very easily sort of made, reverted back to plain text by a quantum computer. So everybody is scared by this perspective. And there have been already recommendations. We are working on one here for the UAE, recommendations which are called for post-quantum cryptography. How should you adapt in order to preserve a modicum of secrecy in your communications, assuming your adversary, the hacker, but could be also government. Hackers are not just individuals. They are organizations and they could be even be governments. So if you assume that your adversary has a quantum computer, what should you do to preserve a modicum of secrecy? This is the danger. If someone builds a quantum computer, not with 5 bits, with a little more, but not many more, it can become a danger for all the world's secrecy of communications in the military, in the financial system, in the banks, but also in the ordinary life of people. We have already little privacy. Privacy would be gone forever. That is the quantum computer danger. On the other hand, the positive part. First of all, we can use the quantum computer itself for increasing security. At Khalifa, we are using quantum in order to store in the quantum bits decryption encryption keys, and this will make communications more secure, because if you use one of those keys, I will know it. So we can give keys around that have in self a physical mechanism by which we can tell whether people are using them. And if they steal the key, we will know, and we will know who stole it and whether it has been used or not. But also think at the search problem. The search problem in tomorrow's society with all this data production is the most important algorithmic problem. How do I find, or how do I organize the right data among, the flooding of data we are getting over the network today? And the quantum computer can make this incredibly fast. It will change database, it will change search, it will change localization of the right information, not only on the internet, but also on the sensors, on the Internet of Things. So, well, it's a fascinating perspective, but also a danger, or both.
للاشخاص البسيطين مثلي انا لا اعرف كثيرا في تقنيات الكمبيوتر انا ولا ميشيل، كيف نبسط هذا التطبيق؟ يعني كيف سيستفيد الشخص العادي من وجود الحاسب الكمي في مرحله متقدمه بعد ان يصبح في السوق بشكل تجاري؟
Well, the quantum computer will not be another computer. I will keep my own computer. The traditional computers are here to stay. You can imagine it as an additional card that goes into your computer. That additional card will contain a few quantum bits. Or alternatively, you can access one of those cards through the network, and you can access, as you can do today for the IBM 5-bit quantum computer, which is available over the internet for people to try it out. So you will have this co-processor. It's not, we won't change as you write your letters or how you deal with your stuff, your email. This will remain traditional. What will be the role of the quantum computer is to help the ordinary computer doing things that require fast solution of problems like, as I said, searching or computing. So the effect will be visible. You don't have to do anything. Just the effect will be visible. But it will be an incredible effect. Your computer will be able to detect in an instant, things that at the moment require minutes. And this changes the perspective of a number of applications. As I said, computations, searches, everything that has to do with computing a function of many, many, many values. And there are so many of those applications in the internet, you don't know at the moment how they work inside. But I can tell you they are slow. They look fast, but the new frontier with the quantum computer will make those applications of today seem like Stone Age stuff. This is what will happen.
شكرا جزيلا لك على هذه المعلومات القيمة، على حضورك معنا. مدير مركز أمن المعلومات والهندسة الكهربائية والحاسوب في جامعة خليفة الدكتور إرنستو دامياني، شكرا جزيلا.
Thank you very much for calling me.